Okay, I'd like to talk to you about my first ballistic gelatin test with the 444 bullets. I did this one a couple days ago. Started off with the Hornady Superperformance ammo with the full factory loading, shot at point blank range, which basically means just roughly 30 feet from the muzzle to the point of impact. We came in over here, and the bullet penetration overall is about 22 and a half inches. We can see right there where it ended. Roughly, first block is 20 inches, and then we went in a total of another 2.5 inches into the second block. Now, the Hornady Superperformance has never been one of the deepest penetrating bullets in my test with the water, and it appears that so far with the ballistic gelatin, it is getting roughly the same depth of penetration. This particular bullet was going 2,339 feet per second. That's 2,339 feet per second. Cronied 15 feet from the point of impact and 15 feet from the muzzle. So right in between there at 30 feet. This bullet right here that we can see, I tested in water at the same time, and this one had 2347 feet per second recorded velocity, so only 8 feet per second difference. This one was captured in the fourth jug, having punched a hole into the fifth jug, but still lying in the fourth. At 22.5 inches in this gel test would put it in the middle of the fourth jug, or towards the back end of the fourth jug. So it's pretty close so far in my first testing here with it. Now, the reason why I wanted to record this video though is because I saw something very interesting in the wound cavity we have here that is not something I've seen on any of the videos that I've watched on YouTube, other ballistic gelatin test videos. As soon as I tested and went and looked at the ballistic gel, I was surprised to see, rather than a big massive singular wound channel, I noticed this sort of spiral, if you can see it there, the spiral in wound cavity. Well, let's go back and look again at the position, the orientation of the bullet. See how it's laying sideways there? The bottom down, the lead core exposed part down, the base of the bullet up. And I took a measurement on the one with the water test here, and what we have roughly is a bullet that averages just about an inch in diameter in the expanded frontal diameter of the bullet. At the same time, the bullet has been reduced down to a depth of about 0.375. So what you have is a bullet that was traveling at like this when it comes in, right? And it flattens out like this, and it hits. And I've often wondered how it maintains its orientation of continuing to go this direction, when all logic says if something shaped like this, without anything really to, keep it directional from the backside, means it's going to flip over, and that's exactly what it did. Now the bullet's also twisting. Now it's a 1 in 20 twist, 20 inch this is a 1 in 38 twist. I used a 24 inch barrel to get these velocities for my 65 444. This thing is spinning when it hits, so that's why we hit up here. The bullet hits, and you can see it's basically, I'm not sure which orientation it is there, but it's turning over as it's rotating, and that's why the spiral. And you'll see in the video as well that the gelatin block is retaining that corkscrew energy as it continues after the bullet's already in a static position over in the second block. The first block continued to spin like a corkscrew, and it fell off the table and everything in the dirt, and that's why it's so dirty. Now we don't see much fragmentation of the bullet, and it seems that there's a little piece of jacket in there, maybe 2 pieces of jacket that I see, little tiny pieces. Alright, now we're going to weigh the bullet that was used in the gel test, and we put this down on the scale, and we're coming up with 267.4. I don't know if you can read that from that angle there. Let me see if I can. No, that ain't gonna help, is it? Anyways, bouncing back between 267.3 and 267.4. So obviously we've got a little bit of gel that's tucked up underneath some of those areas of the jacket that are curled back on itself, that's cupped a little bit of gel up in there, that's actually giving it a weight greater than 100% of retained weight. We'll go ahead and give it a measure. We'll see here. As you can see, as much as that's worth, that's averaging right around 9.16, 1.15, and then the wide section here at about 9.4. So it's just slightly narrower than the one tested at the same time during the water testing. 8 feet per second difference in the two. You can see the water one has a ripple sort of wave effect on it, where the gel one finished with a very smooth finish. Very similar in a lot of ways, the two are. Performance, that's good, shows consistency. And this one on my left hand side is the water test. The one on the right is the gel test. So a little more expansion in the water test version than on the gel test, and a little smoother on the gel, but very similar, very consistent performance between the water and the gel overall.